Hiya. So in this video I'm going to take you through some examples in partial fractions questions. If you haven't seen my introduction to partial fractions video yet, watch that first because that's where I give the detailed explanation of what's going on. With these I'm just going to kind of go through them. Just more some simple extra practice questions for you to look at. Okay. Now just a reminder, why do we do partial fractions sometimes? Well, suppose you need to integrate that fraction. Okay, how are you going to do it? That's just the opportunity for you to think about it a little bit. Partial fractions is the answer, of course. You need to use partial fractions if you want to integrate it. Maybe I'll come back to that at the end of this. Okay. Now, first thing you notice is that the denominator has not been factorised. Very typical with an integration question, I have to say. The method is, when you see a fraction like that, you've got to try and factorise it if you possibly can. Okay, and if you can factorise it, then your method is partial fractions. Don't worry about the numerator. I know the numerator can factorise as 2x minus 7, but there's no point. Okay, with partial fractions, what's important is the denominator is written as a product of distinct factors. Okay, so that factorise as x plus 5x minus 3, won't it? Okay, just check that, 5x minus 3x. Yeah, okay. And then you're ready to go with the partial fractions. Okay, now because I'm going to write the identity sign, I don't want to write the equal sign there anymore. Okay, so I'm just going to write next line, this, which is the same as that, is going to be identical to, and then you've got to set up the partial fractions. Okay, what form will the partial fractions take? Well, hopefully, having seen my first video, you'll know it's going to be a over x plus 5 plus b over x minus 3. Okay, because you see the two different factors on the denominator there, so the partial fractions, the sum of the two fractions has got to be something over x plus 5 and something over x minus 3. Okay, and that's why you need to factorise first. Okay, so you can see how to split up the partial fractions. And then the next stage is multiply both sides by x plus 5, x minus 3. So on the left you've got 2x minus 14, and on the right we'll have a times x minus 3. Remember, we're multiplying by x plus 5, so x plus 5 will cancel, multiplying by x plus minus 3. And then this term will become b, the x minus 3's will cancel, and it'll be x plus 5. Okay. Now, again, if you saw my first video in introduction, I referred to a method 1 and a method 2. Method 1 is always the preferred choice, so that's what I'm going to use. Method 1 is the substitution method. Okay, you find the value of x, you want to substitute in order to work out either a or b separately. And first of all, I'm going to substitute in x equals 3. Hopefully you spotted that, because that will make that equal to 0, you see, and enable us to find out what b is. So on the left hand side, when x is 3, you've got 6, subtract 14, so that's going to be what, negative 8. And on the right hand side, we're going to have 0, and then 3 plus 5, 8, times b, 8b. Okay, and b is equal to negative 1. Okay, and next value to substitute in will be x is equal to negative 5, and so we'll have negative 10 subtract 14, that's negative 24, and then on the right hand side we'll have negative 5 subtract 3, negative 8a, and that means that a will be equal to 3. Okay, and then that's it. Okay, that's it, done. So in terms of writing as partial fractions, the partial fractions will then be a, which is 3 over x minus 3, plus b, which is negative 1. So because it's negative 1, I'm going to write subtract for the fraction. Subtract 1 over x minus 3. Whoops, did you see what I did there? Just x plus 5. I apologise about that. You're probably screaming at me as I was doing it, but the fact of the matter is I can't bother to record the video all over again just for that. Okay, sometimes happens, apologies, but the main thing is I spotted it. Okay, so 3 over x plus 5, subtract 1 over x minus 3. And those are the partial fractions, that is it. Okay, so let's just go back to what I said earlier. What if this was an integration question? What if the question was to integrate that? Well, what you do is you would integrate this, okay? And it's quite simple. Okay, you have 3 times natural log of x plus 5, subtract natural log of x minus 3, plus a constant. Okay, simply done. Okay, hope that you enjoyed the example, hope you found it helpful. There's another one coming right up. Okay, this is my next partial fractions example. Notice you've got 3 distinct factors on the denominator this time. So you've got x minus 1, 2x plus 1. So what form will the partial fractions take? Well, there's going to be 3 of them, clearly, because there's 3 distinct factors. So the first one will be a over x, and then the second one will be b over x minus 1, and the third one will be c over 2x plus 1. Okay, so the method is no different. It's exactly the same as if you've just got 2 distinct factors. You just have 3 of them instead. Okay, and then off you go. Just going to take you a little bit longer, that's all. So what we do now, we're going to multiply both sides of this identity by the whole denominator, x minus 1, 2x plus 1. Okay, it's got a bit of a squeeze to get it all in. Okay, so let's just have a go. So the left hand side, I'm going to write a little bit more smallly, if you don't mind, and scrunched up. Let's try and fit it all in. So you'll have 6x squared plus 5x minus 2. And on the right hand side, don't forget we're multiplying by that and that. This term will become a, and the x's will cancel, so you're left with x minus 1 and 2x plus 1. And then the middle term, b, that will become x, the x minus 1's will cancel, 2x plus 1. Can I fit the whole thing in? Oh, I'll be so upset if I can't. cx, that's such a squeeze, I hate it. 2x plus 1's will cancel, x minus 1. X minus 1. Can you see that okay? Ooh, that is extremely dodgy, I have to say. Okay, but it's the trouble with having just a narrow board. Okay, but there we go, I'm going to work with that one. Okay, so yeah, that's what we got. The method is still the same. You find the value of x that you can substitute in, so you can find your values for a, b and c. The first sensible number to substitute in, I'm going to substitute in x equals 0, okay, because then those 2 terms will cancel. You happy with that? So we'll put in x equals 0. On the left hand side, you'll have negative 2. And on the right hand side, we'll have negative 1 multiplied by 1. So that's negative 1a, so it's negative a. And then, of course, 0, 0. And so you got a is equal to just 2. All right? And then next value to substitute in, I'm going to substitute in x equals 1 next, because then that term and that term will cancel. So x equals 1 will give me on the left hand side 6 plus 5, that's 11, subtract 2, that's 9. And on the right hand side, substituting 1, that will become 0, that will become 0, so you're just left with 1 times, and that's 2 plus 1, 3, so 3b. Okay, and that gives me b is equal to 3, and then finally, what value of x we could substitute in? Negative a half. Okay, it's got to be a fraction, isn't it? In order for this term there and this term there to cancel, so you can find what c is. Okay, so that makes it a bit awkward. So x squared, so that's 1/4, times by 6, so that's 6/4, 3 over 2. And then 5 times negative a half, so that's negative 5 over 2. Subtract 2. And on the right hand side, so 0, 0, and this will be negative a half times by, that's negative a half, subtract 1. So that's negative 3 over 2. Negative 3 over 2 times by negative a half, so that's actually positive 3 over 4. So 3 over 4c. Happy with that? Good. Okay. So 3 over 2 subtract 5 over 2. So that's going to be negative 2 over 2, which is negative 1. Subtract 2, so that's negative 3. So you've got negative 3 is equal to 3/4 c. Okay, so what that means is that the 3's will cancel. You'll have negative 4. Okay, is equal to c. So negative 4. That's it. Done. Okay, so you got a equals 2, b equals 3, c equals negative 4. And I haven't got room to put the final answer on. Well, I'm going to try and squeeze it on down, but I'm doing a lot of squeezing with this example, and I squash that on there, and we'll squeeze this on here. But yeah, partial fractions doesn't normally take up a lot of work in, okay? So the answer is a over x, which is 2 over x, and then plus b over x minus 1, so plus 3 over x minus 1, plus c over 2x plus 1, so subtract 4 over 2x plus 1, okay, and that's it, done, okay. Same as what I said before, don't forget when you do integration, you have to be able to integrate fractions like these, okay, in which case you end up integrating these, but again, you get natural logarithms for each of these terms as you do so. Okay, just a reminder there of one of the reasons why we're doing this, okay, because it does come in the integration chapter later on. Hoping you found that useful. There's another example coming right up. Okay, this is my next example. So it's find this in partial fractions, expressed as partial fractions, 7 over x minus 2, x plus 6, x plus 3, okay. The reason I've chosen this one is because the textbook I'm working from, okay, have put this as a potential example, but not actually worked through it, okay. The textbook has basically said you can find these as partial fractions, but then rather than do that, they then go ahead and do a different example, leaving this one unanswered, which is like, why would you mention that if you don't actually go ahead? So I'm curious as to what we're going to get, and you should be too. I'm guessing that the answers are going to be quite awkward. I've not seen this example before, it's brand new to me, but I'm guessing the examples such as A, B and C are going to be awkward, okay? Well, let's have a look. The partial fractions will look of this form, won't they? A over x minus 2 plus b over x plus 6 plus c over x plus 3. Nothing too awkward so far, okay? So next stage is we'll multiply both sides by the denominator of this. So that means on the left hand side we'll get 7. So I'm just going to try and squeeze everything in if I can. So we've got 7 is the same as, and on the right hand side this will become a x plus 6 x plus 3, and then the middle term b will be x minus 2 x plus 3, and then the last term c times by x minus 2 and x plus 6. God, it's always such a squeeze when there's 3 of these things, isn't it? Okay. Hopefully you're faring better than I am. Okay. There we go. That's it. And what we're going to do, we're going to just start substituting values in. So what values should we substitute in first? X equals, let's go for -3. Okay. So x equals -3. So don't forget the left hand side is always going to be 7 now, isn't it? Because that's not got any x terms at all. Okay. So the left side is always going to be 7. So that's quite nice and straightforward, isn't it? So left hand side is 7. So put in -3, that'll be 0, that'll be 0. What's this going to be? -3 subtract 2, that's -5. And then -3 plus 6, that's 3. So 3 times by -5 is -15. -15c. Okay, so that means c is going to be -7 over 15. Okay, and I think we've just seen why the textbook did not go through this example, because the answers are going to be a little bit awkward. Look, the answers don't become much more awkward than that. -7 over 15. Okay, but never mind. It's a number. Okay, it is a number. It's nothing to be scared of just because it's negative and it's a fraction. It is a number, and that's the business that we're in, isn't it? We're doing maths. We're studying maths, which is the study of numbers. So there's no reason to be scared just because the answers come out to be fractions. Okay, we're not going to cry over it. Okay, so I apologise if some of you have cried. Okay, but yeah, well, you shouldn't be. You're in year 13, for goodness sake. You shouldn't be crying. Right, what's the next value we're going to substitute in? X is equal to, let's go for 2, because that's going to be a nice simple number, isn't it? So the left hand side again is going to be just 7, the right hand side, so 2 plus 6 is 8, and 2 plus 3 is 5, 8 times by 5 is 40, so that's going to be 40a. Okay, and then the 2 means that would be 0, that would be 0, so that means a is equal to 7 over 40. Okay, yeah, another fraction, okay, but it's still a number, it's still fine, it's still valid for working out what this is in partial fractions. Finally, the value to substitute in x is equal to, what have we not done? -6, okay, so the left hand side, again, is 7, and then that will be 0. Here, what have we got? So -6 subtract 2 is -8, -6 plus 3 is -3, -8 times by -3 is 24. Okay, so 24b, and of course that is 0. So that means b is equal to 7 over 24. Okay, so it hasn't been any more difficult, has it, really? Okay, it's not been any more difficult than the previous example I went through. It's just that the answers we've got are a little bit awkward, that's all. Now, in terms of writing down the final answer, so here's what you can do quite simply, okay? A over x minus 2, you can write it like this, 7 over 40 over x minus 2. And then the B, you can write as plus 7 over 24 over x plus 6. And then C, that's negative, isn't it? So that's negative 7 over 15 over x plus 3. Okay? The reason I'm writing like that, I know these aren't strictly proper fractions now because you've got a fraction on the numerator. Okay? The reason I'd recommend writing like that is because often you're asked to integrate these things in the integration unit. Okay? And if you're asked to integrate all of that, then it's going to be easier to write that as 7 over 40 times natural log of x minus 2. 7 over 24 times natural log of x plus 6. Subtract 7/15 times natural log of x plus 3. Okay? The numerator, you see, gives you the coefficient of the natural logarithm term that we're looking for in these cases. So that's the only reason why I'd recommend writing like that. If you wanted to write it more neatly as a fraction, yeah, let me just mark these off, okay, and just put it up here. If you wanted to write the answer more neatly as a fraction, this is what you would do. You'd keep the numerator as 7, but then the 40ths for that, you just include that in the denominator and write it like this. Okay? I'm hoping you can see that that term is exactly the same as that term, except that's how it should properly be written as a fraction. Okay? And then the middle term, you'd have 7 over 24 x plus 6. Again, hopefully you can see that that term is the same as that term. And then the last one, you'd have 7 over 15 x plus 3. And again, hopefully you can see that that term is the same as that term. Okay, it's just that if you're leaving it as a final answer, yes, that's best. But if you're going to have to do something else with it, like integrate, or even use the binomial expansion on it, then that's the one to go for. Okay, I'm hoping you enjoyed the example. I'll see you again.